Hello there everyone, and welcome to another A.I.R tutoring YouTube session. In today's video, we are going to be doing a pre-algebra placement test. This test is meant for a pre-algebra student that has completed the course, or it can also be for a pre-algebra student that is going to be taking the pre-algebra course in the next upcoming week or so. Take this video as an introduction and a taste of what pre-algebra is, and if you are that pre-algebra student that you already finished the course and you're moving on to geometry or algebra or whatever other course you may be seeing, you can also take this as a good refresher and just something to see if you fully understand the concepts and the ideas behind pre-algebra. Go ahead and get started with the first question over here, which is dealing with integers, so adding, subtracting, dividing, and multiplying integers. Here for the first question, we see 11 minus -6. So again, a very good way to think about this is we take that this negative inside of the 6, and we can actually treat it as 11 minus -1 times 6, okay? And a good way that we can think of this is whenever we have a -1 here and a negative sign, right, we can actually cancel them and they'll become positive. Or if you feel more familiar with this, you can call it a negative times a negative, okay? And that will always be positive. You can revert back to this this theorem that negative times negative always equals positive, okay? So here, if this is the case, then basically this becomes 11 plus 6, which will give us 17, okay? If we go over here to the second question, we have -8 plus a -25. So again, we can apply the same rule here as we did to the first problem, where we see that -25. We can think of that as -1 times 25. And then with that -1, we'd have it next to a positive, which, if you remember, again, from pre-algebra, we're taught that a negative times a positive will always give us a negative. Okay, that's another good one to have, and I can put that over here if you want to just have it as reference, but a negative times a positive will always give you negative still. So this is basically going to be -8 minus 25. Okay, and another way you can also think of this is -8 plus a negative number. Think of it just like if you were adding positive numbers. Since they're both the same sign, they're going to want to go further into the negative side. Okay, so we have -8 here, -25, and if we do the quick math on that, we should get -33, if I'm correct on that. Let's go to the next one over here. We have -50 now divided by 5. So just as I was saying with these multiplication rules, the same rules apply whenever we divide. So if we do negative divided by positive, we'll still get negative. Or if we did negative divided by negative, we'll still get positive. So in this case, we do have the one negative and the one positive. So we know for sure negative divided by positive, that's always going to be negative. So for sure our answer will be negative. And then we just do 50 divided by 5, which is very easy, and that would be 10. Yes. And then lastly, let me fix this up over here. There's a multiplication. Okay, so -7 times -5, we've already seen that right over here, right? So negative times negative gives us a positive. So again, the negatives are here, but when they multiply together, they'll be positive, and then we just treat it as 7 times 5, which is going to be 35. Okay, so these are a couple of the types of integer problems you'll be seeing in pre-algebra. Now, if we move on over here to questions 4, 5, and 6, we see exponential problems. And these are very tricky sometimes for students, but if you have the right foundation and know how to properly understand the use of exponents and parentheses, then you should be fine. So I went ahead and wrote both of these kind of the same, but we're going to see how they're a little bit different, and our final solution will vary. So in this case, we have a 5 squared inside of the parentheses. So we go ahead and do that problem first. So we bring forward the negative, keep the parentheses, and inside the parentheses now that's going to change, right? Because we have a 5 squared, which is just 5 times 5. That's another way of saying that, and we're going to get 25. But if you notice, we still have that negative, so the final answer is actually negative 25, okay? In this case, it's a little bit different because now the square is on the outside of the parentheses and the negative is on the inside of the parentheses. So what does this mean? It means that now, if we open up the parentheses again, we're gonna actually, let me break this down a little bit further. But if we break this down, we can actually say that this is going to be negative 5 times negative 5, like that. And then when we multiply these two together, we're going to get negative times negative. Again, falls back to the same principle. Two negatives multiplied will always give you a positive. So positive 25. So just by the sign of parentheses, and depending on where the square and the negative are, our answer changes drastically, actually. If this was a real world problem, just by including or not including the negative inside the parentheses or the square inside the parentheses, you'd have a difference of 50, right? Because when you go from positive 25 all the way to negative 25, that's a whole 50 difference. So very important to know how to work with exponents in their parentheses. Exponents and fractions, kind of easy, not too hard. I mean, again, if you can do exponents, then just one little extra step with fractions. You know that you can split the square into both of these. So whenever we square 2 over 3, we can call it 2 squared over 3 squared. And that should be pretty easy. That's 2 times 2, which is just going to be 4. And that's 3 times 3, which will be 9. Okay. Let's go over here. So we have the square roots. Yes, that's another very important part of pre-algebra. Very easy. It's the opposite of our squares. So our squares want to take the number that they're being applied to and multiply them. The square root, you think of it as what two numbers when multiplied equal 100, and they have to be the same number, of course. So so in this case, what number multiplied twice gives you 100, and obviously the number has to be the same. So the number here, the only one that fits the picture, is 10, and of course you can think about it, 10 times 10 equals 100, right? So keeping this idea with numbers, we can also apply this to variables. So whenever we see a y squared, you just have to think, well, hey, what variable multiplied twice or multiplied by itself will give me this answer on the inside, or this variable on the inside squared? And here the answer would just be y. Okay, and again, we think about it, y times y will equal y squared, just like how 10 times 10 equals 100. Okay, and to finish off this section for today, we have 9 and 10. Okay, so in this case, we are going to be working with order of operations and dealing with exponents, dealing with parentheses, dealing with multiplication, adding, subtracting. So very important to know how to do order of operations and how to specifically solve for a variable in this case. I'm going to go ahead and just start by deconstructing this parenthesis out here. So I'm going to keep everything the same. 8 times 2 plus 5 squared minus y equals, okay, so I'm going to go ahead and distribute this 2 into here, and that is going to give me 2y plus 2 plus 6. Okay, if we have a couple of additions that we can do, you can go ahead and just combine these two. Won't really make too much of a difference. You can also you can also solve for the 5 squared right there. So let's go ahead and do that. Let's bring down that 8 times 2 plus, we do 5 squared. We got that as 25 minus y equals 2y. And then let's also go ahead and join these two over here. That will be a 2 plus 6, 8. Oh, 2 plus 6, 8. Okay, there we go. Now we can go ahead and we can actually go ahead and it would be multiply these two and then add it to the 25. We're following the correct order. So 8 times 2 is going to give us 16 plus 25 minus y equals 2y plus 8. And something that I'm gonna go ahead and do right now is get rid of this y right over here. So, or not get rid of it, but move it over to one side. So the idea that we want to have here is we want to move our y's over to one side and our numbers over to the other. We could have done that here from the beginning, but it's easier to cancel out a couple of your numbers so you don't have to move so many numbers around and maybe get mixed up. So it's a little bit easier when we only have three numbers on, or three terms on one side and 2 terms on the other, okay? So we can go ahead and move y over here. So we do plus y, that's gonna cancel out, and then another plus y over here. A famous thing that you're always gonna hear in math is whatever you do to one side, you have to do to the other. So if I'm adding a y over here, which is gonna cancel out with this negative y, I have to add a y on this side, right? That's the whole idea of an equal sign. If you do it to something on one side, you have to do it to that other side, okay? So here we have 2y plus y, which is 3y. We can also go ahead and add up these two numbers real quick, just because they're numbers and they're on the same side. So it's going to be, I'm going to split it up into 6 and 5, which is 11, and 10 and 20, which is 30. 30 plus 11 is going to give us 41, right? So we got 41 equals 3y plus 8. And this 8, we want to bring it over here. So we subtract that 8. Again, what we do to one side, we have to do to the other. So negative 8. And 41 minus 8, that's going to leave us at, let's see, if we 43, if I'm correct. I'm sorry, 33. Yeah, so 33 equals 3y. And then we go ahead and solve this by dividing the 3. It cancels out right there, dividing the 3, and we'll get that y is equal to 11. And that would be how you solve that. And again, you can always check this by plugging it back into here and making sure it actually gives you the right answer. I would actually suggest plugging it into this part of the simplification, just so that you don't have to get jumbled up with all that stuff. You can just say 2 times 11 is 22. 22 plus 8 should be 30. You have 16 plus 25, which is 41, minus 11 will bring you back down to 30. So we clearly got the right answer here. And finally, to finish off with number 10, it's a little bit easier, but again, if you don't know how to properly understand exponents, then it might throw you off. So let's go ahead and break down that exponent. We're going to get negative 3 squared. Remember, we think of that as negative 3 times negative 3. So that's a negative times a negative, which will be a positive 9, right? And 9 because, again, 3 times 3. Then divide that by 9 and then add 6 to it. And we get our value for D. So that's 9 divided by 9, which is going to be 1 plus 6 equals value of D, and that's pretty easy. 7 is equal to the value of D. And again, you always want to check your work. Plug this value into here, 7, and it's pretty easy this time around because the actual the variable is already on one side, unlike in this first problem where we had to move things around. It's already on that side, so for sure it's always going to be 7. Again, this is just the first part. I'll be uploading the second part very soon, and this has been the pre-algebra placement.